Hello, grade 8 learners! This is Madam Leon and I'll be guiding you as you continue your learning journey in Mathematics 8. So this video presentation is all about adding and subtracting similar rational algebraic expressions, a topic for the 4th week of the first quarter. What you need to know. At the end of the lesson, you are expected to first, define similar rational algebraic expression, and second, you're going to add and subtract similar rational algebraic expressions. Before we start, do you still recall about like fractions? So what are like fractions? So like fractions are fractions having the same denominator. So say for example, we have 1/5 and 3/5 or 3/5. So in here, we have the same denominator which is 5. And for the second example, we have 8/9 and 4/9. And we have the same denominator which is 9. So again, like fractions are fractions having the same denominator. And now, how do we add or subtract like fractions? So to add or subtract like fractions, we simply add or subtract the numerators and keep the common denominator. So say for example, we're going to find the value of 1/5 plus 3/5 or 3/5. So the given two fractions have the same denominator and that is 5. So what are we going to do? We're going to take the denominator once and add the numerator. So we have the numerator 1 and 3. So 1 plus 3 is equal to 4. And copy the common denominator which is 5. So we have 4/5 and that is the final answer. Another example is to get the difference of 8/9 and 4/9. So again, take the denominator once and subtract the numerator. So the numerator is 8 and 4. So 8 minus 4 is equal to 4. And the denominator is 9. So we have 4/9 and that is the final answer. So in symbols, if we have the fraction in the form of a/b plus another fraction in the form of c/b, then we have a plus c/b. And same as true with subtraction. So if we have the fraction in the form of a/b minus the fraction in the form of c/b, then we have a minus c/b. So that is also the same with adding and subtracting similar rational algebraic expression. So by the way, what are similar rational algebraic expressions? So similar rational algebraic expressions are expressions having the same denominator. So say for example, we have 3/x and 2/x. So they have the same denominator which is x. Another example is 5/x minus 3 and 3x minus 2/x minus 3. So the common denominator is x minus 3. Example number 3, we have 2x/9 and 4x/9. So the common denominator is 9. And another example is 2c minus 1/c plus 1 and negative 2c/c plus 1. So the common denominator is c plus 1. How do we add and subtract similar rational algebraic expressions? So here are 3 simple steps. So first, we're going to add or subtract the numerators. Second, copy the common denominator. And third, simplify the result. So in symbols, if we have the rational expression in the form of p/q and r/q, so adding the two rational expressions will give us p plus r/q, and subtracting the two rational expressions, so we have p minus r/q. So again, p/q plus or minus r/q equals p plus or minus r/q. So we simply copy the common denominator and simplify the given result. Let's have illustrative example number 1. So we're going to add 3/x and 2/x. So what are we going to do? So check whether the denominators are the same. So in here, the two rational expressions have the same denominator which is x. So we're going to add the numerators 3 and 2. So 3 plus 2 is equal to 5. And then we simply copy the common denominator which is x. So we have 5/x and that is the final answer. Next, we have example number 2. So we're going to subtract 2x over 9 minus 4x over 9. So again, we have the same denominator, which is 9. So subtracting 2x and 4x, so we have negative 2x. So we have negative 2x over 9, and that is the final answer. And now, let's see example number 3. So we're going to add 5a over 7 and 4a over 7. So what are we going to do? So since the denominator is 7 and they are common, so we're going to add or combine like terms. So what are like terms? Like terms are terms having the same variables and exponents. So if that is the case, we simply add the coefficients. So we have 5a and 4a. So we have like terms. So simply add the coefficients or the numerical coefficients 5 and 4. So 5 plus 4 is equal to 9. And we simply copy the common variable, which is a. So we have 9a over 7, and that is the final answer. So example number 4, we're going to add 8n plus 3 over 2 and 2n minus 7 over 2. So what are we going to do? We're going to collect the numerators. So we have 8n plus 3 plus 2n minus 7, and then copy the common denominator. And then next, we're going to combine like terms. So we have 8n plus 2n, which is equal to 10n. And then we have plus 3 minus 7, and that is equal to minus 4 or negative 4. So for the numerator, we have 10n minus 4, and the common denominator, which is 2. So what's next? We're going to factor the GCMF in the numerator. So what is common to 10n and 4? So 2 is common to 10n and 4. So the factored form is 2 times the quantity 5n minus 2 over the common denominator, which is 2. So what's next? We're going to divide out the GCF in the numerator and denominator. So we're going to cancel out 2. So what's left is 5n minus 2. And 5n minus 2 is the sum in the reduced form. So 5n minus 2 is the final answer. And now, what if one denominator is opposite or the additive inverse of the other? So this question can be answered using example number 5. So we have x squared minus 2 over x minus 1 minus x over 1 minus x. So we have denominators which is the opposite of the other. So what are we going to do? First, we're going to rewrite 1 minus x in terms of x minus 1. So how are we going to do it? We're going to use the commutative property of addition. So we have 1 minus x equals negative x plus 1. And then we're going to factor out negative 1, giving us negative 1 times the quantity x minus 1. So we have equivalent terms. And then next, we are going to simplify the second term. So x over 1 minus x. So this is equivalent now to x over negative 1 times the quantity x minus 1. So simplifying the term, we have negative x over x minus 1. So we have now similar denominators. And then, what are we going to do next? We're going to collect the numerators. So we have x squared minus 2 minus negative x over the common denominator, which is x minus 1. So next, we're going to multiply successive signs. So we have negative times negative x is positive x. So we have now x squared minus 2 plus x over the common denominator, which is x minus 1. And then we're going to rearrange the terms of the numerator. So we have x squared plus x minus 2 over the common denominator, which is x minus 1. And then what's next? We're going to factor the numerator. So the factors are x plus 2 and x minus 1. Since x times x is x squared, the middle term is 2x minus x, and the last term or the constant is negative 1 times 2 is negative 2 over the common denominator, which is x minus 1. And then we have a common factor, which is x minus 1. So dividing out the GCF, which is x minus 1, so what's left is x plus 2, and x plus 2 is the final answer or the answer in simplest form. So we have x plus 2, the difference of x squared minus 2 over x minus 1, and x over 1 minus x. And now, let's see how well did you learn. So for the evaluation, you're going to perform the indicated operation. So, you may submit your answers to your respective teacher to check whether you got the correct answer or not. Well, that's all for today about adding and subtracting similar rational algebraic expressions. So again, always remember that you always add or subtract the numerators and then copy the common denominator and then simplify the result. So, have a good day. Thank you for watching.